Gauss law. Total charge of 6,3 times 10 to the power of negative 8 coulomb is distributed uniformly throughout a 2,7 centimeter radius sphere. The volume charge density is E, 7,6 times 10 to the power of negative 4 centimeter per meters cubed, 7,6 kilo 76 millimeter moles. The charge is placed on the surface of a 2,7 centimeters radius isolated conducting sphere. The surface charge density is uniform and has the value 6,9 times 10 to the power of negative 6 centimeter per meters cubed. The total charge on the sphere is D, 6,3 times 10 to the power of 8. 663 G63 times 10 to the power of negative 8. A spherical shell has an inner radius of 3,7 centimeter and an outer if charge is distributed uniformly throughout the shell with a volume density of 6,1 times 10 to the power of negative 4, the total charge is A, 1 times 10 to the power of negative 7. So a cylinder has a radius of 2,1 and a length of 8,8 centimeter. Total charge is 6,1 times 10 to the power of negative 7 coulombs distributed uniformly throughout. The volume charge density is D, 5,0 times 10 to the power of negative 3 centimeter per meters cubed. When a piece of paper is held with one face perpendicular to a uniform electric field, the flux through it is 25 Newton meters squared per degrees. When the paper is turned 25 degrees with respect to the field, the flux through it is D, which is 23 newtons per meter squared, from 25 to 23. The flux of the electric field, they give us the equation 24 newtons per centimeter, 24, 30, 16 through a 2,0 meters squared portion of a YZ plane is D, 48 newton per meter squared per coulomb, 48 meters squared per coulomb. So consider Gauss law. We have this integral. Which of the following is true? C is true if three particles inside have plus Q and negative 2Q, then the integral is 0. A charge point particle is placed at the center of spherical Gaussian surface. The electric flux, is phi E, is changed if the point charge is moved to just outside the sphere. Choose the incorrect statement. So according to Gauss law, if a closed surface encloses no charge, then the electric field must vanish everywhere on the surface. On the outer surface of the cardboard center of a paper towel roll cannot be a Gaussian surface because it is not a closed surface. A physics instructor in an anteroom charges an electrostatic generator to 25 microcoulomb, then carries it into a lecture hall. So the net electric charge in Newton meters squared per coulomb through the lecture hall walls is D, which is 2,8 times 10 to the power of 6. A point particle with charge Q is placed inside the cube but not at its center. The electric flux through one of the sides of the cube is E. Cannot be computed using Gauss law. 13. A particle with a charge of 5,0 microcoulomb is placed at the corner of a cube. The total electric flux in newtons per meter squared per through all the side of the cube is E, 56 times 10 to the power of 5. A point particle with charge Q is at the center of a Gaussian surface in the form of a cube. The electric flux through any of the one surface of a cube is D. Q over 6 has 6 sides. The table below gives the electric flux in Newton meter squared per C through the ends and round surfaces of 4 Gaussian surfaces in the form of cylinder. Ring of the cylinders according to the charge inside from the most negative to the most positive. E 4, 3, 2, 1 Artama Fasere Audi. A connecting spheres of radius 0,001 has a charge of 1,0 times 10 to the power of -9 deposited on it. The magnitude of the electric field in Newton per coulomb just outside the surface of the sphere is C 900. A round waste paper basket with a 0,15 Newton meter radius opening is in a uniform electric field of 300 newtons per coulomb, so perpendicular to the opening. So the total flux through the sides and bottom in Newton meter squared per coulomb is C, which is 21. So 18, we have 10 coulomb of charge are placed on a spherical conducting shell. A particle with a charge of -3 coulomb is placed at the center of the cavity. The net charge on the inner surface of the shell is D, which is +3 coulombs. So 10 coulomb of charge are placed on a spherical conducting shell. A particle with a charge of -3 coulombs is placed at the center of the cavity. So the net charge on the outer surface of the shell is E, +7 coulombs. So, and then A, which is a 30 Newton per coulomb, Ola 7, a 30 Newton per coulomb uniform electric field. It points perpendicular towards the left face of a large neutral conducting sheet. The surface charge density in centimeter per meters cubed on the left and the right surfaces respectively are A, -2,7 times 10 to the power of -9, +2,7 times 10 to the power of -9 coulomb per meter squared. A solid insulating sphere of radius r contains positive charge that is distributed with a volume charge density that does not depend on angle but does increase with distance from the sphere sent. Which one of the graphs below might give the magnitude E of the electric field as a function of the distance r from the center of the sphere? The answer is D. Okay, D. What's the shape of D? It's like a market graph. Which one of the following graphs represent the magnitude of the electric field as a function of the distance from the center of a solid charged conducting sphere of radius r? What's the difference between that question and this question? This one, we're going to go to step up. This one, they just went straight. Okay, that one, they took a long road. This one, they just went straight and then down. Charge Q is distributed uniformly throughout an insulating sphere of radius r. The magnitude of the electric field at a point of r/2 from the center is D. Q over 8 pi E/O r squared. Positive charge Q is distributed uniformly throughout an insulating sphere of radius r centered at the origin. So a particle with positive charge q is placed at x is equals to 2r on the x-axis. So the magnitude of the electric field at x is equals to r over 2 on the x-axis is what? Is d. I'm going to say q over 8 pi EO r squared. So positive charge q is distributed uniformly throughout an insulating sphere of radius r centered at the origin. A particle with positive charge q is placed at x is equals to 2r on the x-axis. The magnitude of the electric field at x is equals to r divided by 2 on the x-axis is c q over 72 pi EO r squared. Charge q is distributed uniformly throughout a spherical insulating shell. The net electric flux in Newton meter squared divided by Coulomb through the inner surface of the shell is A, which is 0. Why is this one? Why is it different from from 25? Charge q is distributed uniformly throughout a spherical insulating shell, so the net electric flux in Newton meters squared divided by Coulomb through the outer surface of the shell is B q over EO. Oh, that one is inner. If it's inner, it's 0. If it's outer, it's q over EO. A 3.5 centimeter radius hemisphere contains a total charge of 6.6 times 10 to the power of -7 coulombs. The flux through the rounded portion of the surface is 9.8 times 10 to the power of 4 Newton meter squared divided by the flux through the flat base is what? Is C -2.3 times 10 to the power of 4 Newtons meter squared per coulomb. -2.3 times 10 to the power of 4 in 2003, but negative. Charge is distributed uniformly along a long straight wire. The electric field 2 cm from the wire is 20 newtons per coulomb. The electric field 4 cm from the wire is what? Is 10. So you take that 20 divided by 2, it gives you 10. Positive charge q is placed on a conducting spherical shell with inner radius r1 and outer radius r2. A particle with radius q is placed at the center of the cavity. The magnitude of the electric field at the point in the cavity, a distance r from the center, is what? C. It's q over 4 pi EO r squared. Positive charge q is placed on a conducting spherical shell with inner radius r1 and outer radius r2. A point charge q is placed at the center of the cavity. The magnitude of the electric field at a point outside the shell, a distance r from the center, is d. So you add q yinyane q hulu divided by 4 pi EO r squared. Go slow. Positive charge q is placed on a conducting spherical shell with inner radius r1 and inner radius r2. How does this differ from the last question? But anyway, the answer is small q divided by 4 pi EO small r squared. So vertical, which is small. A long line of charge with lambda L charge per unit length runs through the cylindrical axis of a cylindrical shell which carries a charge per unit length of lambda C. The charge per unit length on the inner and outer surface of the shell respectively are B negative lambda L and lambda C plus lambda L. So charge is distributed uniformly on the surface of a large flat plate. The electric field 2 cm from the plate is Newton per coulomb. The electric field per centimeter from the plate is 30 newtons per coulomb. Over 30. Okay, 30 must. Okay, two large insulating parallel plates which carry charge of equal magnitude, one positive and the other negative. So there is distributed uniformly over their inner surface. So you rank the points 1 through to 5 according to the magnitude of the electric field. C is the answer. So it's 1, a jamba J2, raga wire 4, 1, 4, and 5 tie. So 1, chichaka monthly dia tayana, and the chichaka maral jona dia tayana. What about this one? From least to greatest, E. Chichaka mar dia tayana, chichaka dia tayana, obviously. So a particle with charge Q is placed outside a large neutral conducting sheet. At any point in the interior of the sheet, the electric field produced by charges on the surface is directed towards Q. A hollow conductor is positively charged. A small uncharged metal towards Q. Q. A hollow conductor is positively charged. A small and an uncharged metal ball is lowered by silk thread through a small opening in the top of the conductor and allowed to touch its inner surface. After the ball is removed, it will have no appreciable charge. So a spherical conducting shell has charge Q. A particle with charge Q, small charge Q, is placed at the center of the cavity. The charge on the inner surface of the shell and the charge on the outer surface of the shell respectively are D, negative Q, and then small q plus big Q.